Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about recommendation system. This topic is based on a tech blog with the title Candidate Generation Using a Two-Tower Approach with Expedia Group Traveler Data, written by the machine learning scientist from Expedia. You can find the blog link in this episode's description. Throughout this episode, we will dissect the topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Expedia Group is a global travel and technology company that operates a diverse portfolio of online travel brands. It connects millions of users with an extensive range of travel options. This includes flights, hotels, and activities. Given the vast array of choices available on Expedia Group's platform, a recommendation engine becomes integral to enhancing the user's experience. This intelligent system employs sophisticated algorithms to analyze user preferences, historical interactions, and contextual data, so that it provides personalized recommendations tailored to individual needs. This not only simplifies the decision-making process for the customers, but also contributes to better user satisfaction and retention. This ensures a long-term success for the business. The architecture of a recommendation system is typically not just a simple machine learning model. It usually adopts a two-stage structure, strategically divided into candidate generation and ranking phases. This design is particularly beneficial when dealing with large item catalogs, such as those found in the diverse regime of Expedia Group's offering. The first stage is called candidate generation. In this stage, the system efficiently narrows down potential recommendations from the vast pool of items. Following this, it is the second stage of the recommendation system, which is called the ranking stage. In this stage, it refines the selection and fine-tunes the recommendation based on user preferences. The machine learning models used in the candidate selection stage are usually much simpler during the serving time and target for high scalability, while the machine learning models used for the ranking stage can be much more advanced and complex. This structured approach not only enhances the scalability of a recommendation system, but also ensures that the final suggestions are both diverse and tailored to the specific needs and preferences of the user. The goal to optimize the overall user experience. Now that we've understood what a recommendation system is and its two stages, our focus will be on the candidate generation stage. Let's take a look at the specific modeling architecture suggested by the Expedia's machine learning team to be used in this stage. The team shared a powerful architecture called the two-tower neural network. The two-tower neural network architecture is a potent framework employed in the candidate generation stage of the recommendation system. The architecture comprises two main components: a query tower and an item tower. The query tower examines information related to you, the customer, such as your past searches, the things you've clicked on before, or what you might be interested in based on your history. It learns to understand your unique preferences. On the other hand, the item tower looks at details about the options. For example, details about hotels or flights, considering features like location, popularity, and amenity for the Expedia lodging. Each of the tower is built with encoder neural network architecture. The output of these towers is then interacted through operations like the dot product and fed into activation functions like softmax or sigmoid. And the output of each of the tower must be the same size due to the final dot product interaction in the network. This process efficiently scans through the vast item corpus, generating a subset of potential candidates for future ranking and refinements in the recommendation system. The two-tower architecture's scalability and adaptability makes it particularly effective in handling large-scale databases and diverse recommendation use cases across different domains. The author also shares how to develop the two-tower model using their open-source traveler data, along with the TensorFlow implementation. However, it is quite code-heavy, and if of interest, I would suggest taking a closer look at the blog for more details. Once the model is built, to evaluate its performance, the team selected the main metric as recall at k. Recall at k is a metric used to assess the performance of a retrieval system. The recall aspect of the metric refers to the system's ability to retrieve relevant items or documentations, while the at k specifies the number of top-ranked items or documents to consider. For example, if a recommendation system is tasked with suggesting 10 items, and there are a total of 20 relevant items in the database, a recall at 10 of 0.7 would indicate the system successfully retrieved 70% of the relevant items within the top 10 recommendations. Recall at k is a valuable metric for assessing the comprehensiveness of a recommendation system, and this is particularly important in the scenario of candidate generation. It can provide insights into how well the candidate generation stage performs in terms of capturing items that users are likely to find interesting or relevant. Now we discussed both the business problem and technical solution. Let's wrap it up. In this episode, we discussed the two phases of a recommendation system: candidate generation and ranking. We explored an efficient two-tower neural network architecture and also gained an understanding of the appropriate metric for assessing the success of candidate generation. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.